Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. We are in the unit of number systems, and so this time we're going to look at an equation where the number or the base is not given. So we don't know what base the equation is written in, and we're asked to find what that base is. And so let's look at how we solve a problem like this. So we're going to find an unknown base from an equation. The solution is that we're going to write the polynomial with the base as a variable, and that's solved. So let's do an example. So what if we had the expression that 15 multiplied by 4 is 1/12. Now, I've read that incorrectly because we don't know the base, and that was using decimal language. So this would be 15 multiplied by 4 is equal to 112, right? And we want to know what the base of these numbers is. So let's create a variable, b, where base is equal to b, and then write out the polynomial. So we have 1 times b to the 1 plus 4 times b, multiplied. Oops, no, let's restart, because I made a mistake. So we got 1 times b to the 1 plus 5 times b to the 0. That's our 15. And that whole thing is multiplied by 4 times b to the 0. And that equals 1 times b squared plus 1 times b to the 1 plus 2 times b to the 0. So that gives us b plus 5 all multiplied by 4 is equal to b squared plus b plus 2. So let's do this distribution. So we have 4b plus 20 is equal to b squared plus b plus 2. So, and then to put everything on one side, we have b squared minus 3b minus 18 equals 0. And then we can break this up into factors here. So we have b on this side, and so we have a negative number, so one of these is going to be negative, one of these is going to be positive, right? So negative 18. And we have to have the difference be 3. So it makes sense here that the two numbers here are 6 and 3. So b minus 6 and b plus 3. So that solves to b is equal to either positive 6 or negative 3. We're going to choose the positive, and so our base is base 6. Great. So that's how we do it. So let's look at another example. So here's, oops. There we go. Okay, so here's number 2. What if we had the expression 132 plus 21 is equal to 213? So I have sort of a hint here in that none of these digits goes above 3. And so our base might be pretty low. It doesn't have to be, but there's something to consider there if you have no digits that are 5, 6, 7, that kind of thing. So let's just write it out though and do this formulaically. So we have 1 times b squared plus 3 times b to the 1 plus 2 times b to the 0 plus 2 times b to the 1 plus 1 times b to the 0 is equal to 2 times b squared plus 1 times b1 plus 3 times b to the 0. And so we have b squared plus 3b plus 2 plus 2b plus 1 is equal to 2b squared plus b plus 3. Let's collect terms on this side. B squared plus 5b plus 3 is equal to 2b squared plus b plus 3. And then let's get everything onto one side. So we get 0 is equal to b squared minus 4b, and that's it. And so this is equal to b multiplied, distribute out one of the b's, b minus 4. So our b could equal 0 or positive 4. Well, the 0b doesn't do anything for us, so we're choosing positive 4. So our base is base 4. Now you can always do a check of placing that base 4 back in to make sure that this all works out. I'm not going to do that for you here, but that's our process. Here we determined the unknown base from a given equation. I'm Mike Stancic. This is Digital Electronics Classroom. Thanks a lot for watching this video, and I hope you had found it to have value for you. Have a nice day.